Hi everyone, so it's Coach Fred here, and today I'm going to be going over more on logs for the ACT. And we're going to start with looking at a log where you're asked to solve given some logs. So they told us that log 5, so log base 10 of 5, because there's no base written there, is 0.69897. And log 2 is 0.30103. They want us to find log 50. So the easiest way to do that is try to represent 50 using the number 5 and the number 2. That way you can use substitution. So if I think about this, I can actually write this log 50 as log 5 squared, because that's 25 times 2. 25 times 2 would give me 50. Now, using the properties of logs that you've learned in Algebra 2, when logs are written with multiplication, you can separate them with addition. So I can rewrite this like that. Another property you've learned in Algebra 2 with logs is that if a number of a log is raised to an exponent, you can bring that exponent to the front. So we can rewrite this as 2 log 5 plus log 2. Now that you've done that, you can take the values that you know and you can plug them actually right in. So we can write this as 2 times 0.69897 plus 0.30103. And this would be where you'd grab your calculator. So 2 times 0.69897 is 1.39794 plus 0.30103 plus 1.39794 would give me that would give me 1.69897, and I'm guessing that on the ACT they would actually ask you to round it, probably in this case, to the nearest hundredth. So the nearest hundredth, you'd round it to 1.70. All right, let's look at another example. So if y equals 2 to the x and y is equal to 3, approximately what is x? So let's think about this for a second. So if y is 3, if we think about the word equals and what that means, equals means is the same as, well, we know that 2 to the 1 would make it 2, right? So 2 to the 1 would be 2. And 2 to the 4 would be 3. I'm sorry, 2 to the 2 would be 3. Okay, I'm wrong. I keep writing this right. Okay, so we know that we know that 2 to the 1 would equal 2, and 2 to the 2 would equal 4. So wouldn't, in your mind, 2 to the 1.5 equal 3? It's just a way of thinking about what the word equals means with logs. Now, you could solve this using a log equation. Remember, the inverse of an exponential function is a log function. So we could take the log of both sides if we wanted to. So we could take the log of both sides, getting log 3 equals log 2 raised to the x. We could bring that exponent to the front and get x log 2 log 3. And then we could solve for x by dividing by log 2. Now this would be where we'd grab our calculator and we would do log 3 divided by log 2, and we would get 1.58. So you can see that we were really, really close. Okay, all right. Solve for x in the following equations. Okay, so we've got an equation. We also have subtraction in this equation. And so when we're solving equations with logs, it's really great if we can get to the goal of, if you can get a log of something equals the log of something, then you can use the one-to-one property and the idea that equals means is the same as. So I saw that subtraction. So one of the properties I learned about subtraction with log expressions was that I could bring them together using division. So I can write this as 24 over 3. Okay. All right, so this one's going to give me log base 2 of 8 equals log base x of 27. Well, that's kind of funny because 8 and 27 don't necessarily relate to each other, do they? All right, so I'm going to try and figure out ways for me to rewrite this. So if I think about this a little bit, I could write 8 as a base 3 number. So I could rewrite 8 as 2 cubed. And then I could use the laws of logs and bring this to the front. That gives me, okay, so take a second and look at what I did there. All right, so that gives me 3 times 1, which is 3. Log base 2 of 2 is 1. 2 to what power equals 2 is 1. So 3 equals log base x of 27. So in this case, I can now write it exponentially, even though it's backwards. I can do x to the 3 equals 27. So what number raised to the 3 power gives you 27? Well, that would be the number 3. All right, so hopefully these are just helping you remember the log rules you learned in Algebra 2. If not, hopefully this is just a nice way to learn them. Okay, so how can we simplify the expression into a single log? We've got to use all those rules together. So you want to work backwards. So the first thing I notice is this 3 and this 1/2. So I'm going to bring those back to where they started, which would be as exponents to the log expression. So we could write that as log base x cubed plus log base 4y to the 1/2 power minus log z. All right, when it's addition, we can bring them together using multiplication. So that would be log x cubed times 4y to the 1/2 power, okay, minus log z. When it is subtraction, we can bring them together using division. So that's going to give me log x cubed times 4y to the 1/2 all over z. Notice that I'm writing it as one fraction, not log and log. Right now I can probably simplify that a little bit because to the 4y to the 1/2 means the square root of 4y, which means 2 square root of y. So I'm going to rewrite that as log 2x cubed root y all over z. All right, and that's how you condense. We call that condensing logs. You may remember that from this year and what you learned about logs. Just a few more and then we'll stop. All right, a little bit harder. Log equations where there's no logs. So here I have an exponential equation. 5 to the x plus 1 equals 60. There's no way for me to make the bases the same, so I'm going to have to do the inverse operation, which means I'm going to have to take the log of both sides. All right, so I'm going to take the log of 5 to the x plus 1, and I'm going to take the log of 60. Now I want to use those properties that we just talked about, and I want to bring that x plus 1 to the front of log 5. Now remember, the goal is to solve for x. So to isolate x, the first thing I can do is, because these are actually expressions being multiplied, is divide by log 5. So now I have x plus 1 equals log 60 divided by log 5. Now I can just subtract from 1 from that entire quantity. So I'm going to grab my calculator now and I'm going to put in log 60 divided by log 5, which gives me 2.54, and then I'm going to subtract 1, so giving me 1.5439. And you're going to look carefully at what they ask you to round to. All right, guys, I realize that was a lot of information, but my goal here for you was just to review some of the things you learned in Algebra 2 about log equations. I'm going to go over tons of log type problems in the ACT in my videos, so this is just one of many to review those topics. If you have any questions, please leave a comment, and if you like this video, give me a thumbs up. Thanks so much.